Hello, and welcome to the Sleepless Scientist, a quiet corner of the cosmos where your thoughts can breathe and curiosity drifts into calm. Tonight, we'll wander into a question that seems simple, yet reaches through physics, philosophy, and the very fabric of reality itself. Does the past truly disappear, or does it remain, moving silently beside us like a shadow made of time? Before we begin, if these gentle explorations bring you peace, I'd be grateful if you take a moment to like this video and subscribe, only if it feels right to you. And when you're ready, leave a comment and tell me where in the world you're listening from and what time it is there right now. It's always a quiet wonder to see how far this little constellation of a listener stretches, each of us drifting through our own moment in time. Now go ahead and dim the lights. Let the hum of the night settle around you, and together, let's take a slow journey into memory, motion, and the hidden persistence of the past. And if your mind begins to wander, that's perfectly all right. Let it drift. We'll still be here, quietly unfolding the story. If you've ever stood outside on a clear night, with the air still enough that even the sound of your own breathing feels loud, you may have noticed how the stars seem to hold still, shining as if they've been waiting there forever. But those stars aren't showing you the now of their lives. They're showing you the light they sent a long time ago. Minutes ago if it's the sun, years ago for the brighter stars nearby, thousands or millions of years ago for most of the tiny twinkling points you can barely see. When you look up, you're peering through time itself. The sky's an archive and you're reading its pages. It's an odd thought. Even here on Earth, the present is always just out of reach. The sunlight on your hand is already 8 minutes old by the time you feel its warmth. The voice of a friend across the room takes a small fraction of a second to reach you, and your eyes take even longer to process what they've seen. Even a reflection in the mirror is slightly delayed, the light bouncing to the glass and back before your mind puts the image together. This delay is so tiny we don't notice it, but it's always there. A quiet reminder that now is never as immediate as it feels. We usually think of the past as something left behind, a set of moments that slip into memory and can never be revisited. But the universe doesn't work in quite the same way as our minds do. While we forget, the cosmos holds on to things. The light that leaves a star keeps going, carrying the shape of that star at the exact instant it departed. The ripples in space-time from a distant collision continue to spread, long after the event itself. Fossils remain locked in stone for millions of years. The atoms in your own body carry a history billions of years long. You could think of it as a kind of cosmic photography. The universe takes snapshots, not with a camera, but with light, gravity, and matter, and those snapshots drift onward, sometimes for billions of years until something or someone happens to look at them. Every glance at the night sky is like opening a letter that has been travelling toward you for an unimaginably long time. And that brings us to the strange heart of tonight's question. If so many traces of the past are still here, in light, in matter, in the deep structure of space-time, is the past itself still out there in some way? Or are these traces just echoes in an empty hall, the memory of something that's truly gone? Physics doesn't answer this in a way that's entirely satisfying for the human heart. Some theories, like the block universe, suggest that all moments, past, present, and future, exist side by side in a grand four-dimensional structure, like the pages of a book that's already been written. In that view, the past never really leaves. We just move our awareness forward through the pages. Other perspectives, like presentism, say that only the current moment is real, and the past survives only in its effects. The truth is, we experience time in a way that is deeply personal and deeply limited. To us, time feels like a river, moving in one direction, carrying us forward. But in the equations of physics, there's no preferred flow. The laws are the same whether you run them forward or backward. What gives us our sense of direction is entropy. the slow drift from order to disorder, from unlikely arrangements to more likely ones. It's why we see eggs breaking but never reassembling, rooms getting messy but not tidying themselves without effort. Entropy's gentle push is what makes the past feel gone and the future feel open. Still, the next time you see sunlight pour through your window, or hear a friend's voice from across the street, or look up at a star you might remember, you're not seeing the present. You're seeing what was, and in a way, what was is still here, still travelling, still arriving at your eyes and ears. The past, in its own patient way, is never in as much of a hurry to leave as we imagine. Tonight, we'll walk slowly through the many ways this is true. We'll look at the models of time that suggest the past is still here, the physical messengers, light, gravity and quantum threads, that carry its imprint, and the records written in stone, ice, and the atoms within you. And then, perhaps we'll return to this quiet moment with a softer understanding of how the past and present touch. So settle in. The pages of the sky are open, the stars are still speaking, and we have all the time in the world to listen. If you close your eyes and think about time, it's almost impossible not to imagine it as a line. Maybe you see it as a neat row of calendar pages, flipping forward with a steady rhythm. Or perhaps it's more like a flowing river, carrying you along at a pace you can't change, past landscapes you can only see once. For most of us, this is what time means. A journey from the past into the future, with the present as a narrow bridge between them. The past is behind you, the future ahead, and your feet never stop moving. It's such a powerful feeling that it can be hard to question it. We grow up with clocks ticking on the wall, digital timers counting down in glowing numbers, seasons turning over and over like the cycle of breathing. Every story we hear, from childhood fairy tales to the most complex histories, is told in this shape. Once upon a time leads to and then, which leads to and finally. That shape feels natural. It feels like the only way the world could work. And yet, when you turn to the language of physics, the river becomes less certain. The equations that describe how planets move, how light bends, how particles interact, they are, for the most part, perfectly happy to run backward as well as forward. If you wrote them down on a page and read them from bottom to top, they would still describe a perfectly possible universe. The laws of motion, electromagnetism, and even quantum mechanics in their simplest form do not contain any special instruction that says, move only toward the future. So why don't we see glasses of water leaping up from the floor to reassemble themselves on the table? Why doesn't heat flow from colder objects into warmer ones, or smoke drift from the air back into the match that created it? This is where the arrow of time appears, not from the deep structure of the laws themselves, but from the way the universe is arranged. The arrow of time is guided by something called entropy, a word that sounds technical but can be understood in simpler terms. It's a measure of how spread out, mixed up, or disordered a system is. Imagine a neat pile of coloured marbles in one corner of a box. Over time, if you shake the box, the marbles will scatter until they're spread evenly across the whole space. You don't need to tell them to do that, it's simply the most likely arrangement. It's not that the reverse is impossible, but it's so fantastically unlikely that you could shake the box for the lifetime of the universe and never see the marbles neatly gather themselves again. The same principle governs everything around you. A cup of hot tea cools down because heat naturally spreads out into the surrounding air. A drop of ink swirls through water until the colour is even. Stars burn through their fuel, scattering energy outward into space. Entropy increases, and with it comes the sensation of time moving forward. It is as though we live in a world where the deck of cards is constantly being shuffled, and although the laws of the game allow an unshuffling, the odds are so poor that it never happens. There's a certain poetry in this. The moments of our lives, the way the furniture in your room is arranged right now, the exact position of your hands, the warmth of the air, are all specific, unlikely patterns. Over time, these patterns dissolve into more likely ones. the tea cools, the paint fades, the footprints on the beach are erased by the tide. This drift from unlikely to likely, from ordered to disordered, is what gives us the sense that the past is fixed and the future is open. But there is a tension here. In our experience, the past feels gone. We can't return to it. We can't change it. Yet in the quiet language of physics, the rules don't say it has vanished. They don't even say it's over. They simply describe how one arrangement becomes another, in either direction. The reason we don't notice the reverse is not because it's forbidden, but because the starting conditions of our universe were so incredibly ordered that the shuffling process has been moving in one direction ever since. Some scientists have wondered if the arrow of time might be more like a local phenomenon, something that could point in different directions in different parts of the universe. In some distant galaxy, the increase of entropy might look like it runs the other way. The beings who live there would have their own sense of forward, and it might not match ours. In that sense, the river of time could have many currents, many branches, and our small part of it happens to flow this way. This is where our picture of time begins to loosen. It's not a single stream running from a single source to a single sea. It may be more like a vast branching delta, or a network of underground rivers, some flowing in directions we could never follow. And in this web, the past, present and future may not be as separate as they seem from the shore where we stand. For tonight though, it's enough to rest in the thought that the arrow of time, this one-way feeling we live inside, is not an absolute command of nature, but a reflection of how our world began and how it has unfolded since. The river carries us forward because of the way its waters were set in motion long ago. And if the laws themselves have no preference, then perhaps the past is not gone in the way we imagine. It may still exist somewhere, like an upstream bend we can no longer see, but whose waters still join the flow beneath our feet. As we move onward, we'll step from this feeling of time as a current into the stranger, broader landscapes of theory, worlds where the past, present and future are not separate chapters, but pages lying side by side. But before we open that book, let's linger here just a little longer, listening to the quiet rush of the river we thought we knew. If I told you that you have never actually seen the present moment, you might pause, glance around the room and think, of course I have, I'm seeing it right now. But the truth is more slippery. Every single image your eyes take in, every sound your ears receive, every touch you feel, all of it has already happened by the time you notice it. The delay might be so small that you would never notice in daily life, but in the strict sense of physics, you are always living in the aftermath of events. The present, in the way we imagine it, is always slightly out of reach. Consider the simplest example, your own reflection. When you stand in front of a mirror, it feels like you're looking directly at yourself in this very instant. But light takes time to travel from your face to the mirror and back to your eyes. It is only a tiny fraction of a second, so small that it feels immediate, but it is still the past. If you had a mirror on the moon, the light would take about 2.6 seconds to make the round trip. You would see yourself as you were a couple of heartbeats ago. Move that mirror to a distant planet, and you could be looking at a version of yourself from years in the past. The further away the reflection, the deeper into your own history you would be peering. The same is true of the voice of a friend standing across the street. Sound travels much more slowly than light, so there is a noticeable lag if the distance is great enough. At a concert, you can sometimes see the singer's lips move before you hear the words. It feels strange in that moment, because you are reminded that the present is staggered, stretched, and stitched together from countless signals arriving at different times. Now take that idea and expand it outward to the scale of the cosmos. When you look at the moon, you see it as it was just over a second ago. The sun's light takes a little more than 8 minutes to reach us. The light from the nearest star beyond the sun, Proxima Centauri, is already 4 years old when it arrives. That means when you look at it tonight, you're looking at something that happened when your life was 4 years younger. And for galaxies millions or billions of light years away, You are looking not at their present state, but at scenes that unfolded long before humans even existed. It is tempting to think of this as a kind of time travel. In a sense, it is, not the Hollywood kind with flashing machines and sudden leaps, but a quiet, patient kind. The universe has been sending out these messengers of light and sound and gravity, each carrying the imprint of where and when they began their journey. We do not summon them. They arrive on their own schedule, and we happen to be here to catch them. Astronomers take advantage of this every day. Their telescopes are not just looking into space, but into the past. When they study a star-forming nebula a few thousand light years away, they are seeing the light that left when humans were still carving the first tools. When they look at the faint glow of a galaxy billions of light years distant, they are seeing an era when the Earth itself was still young. The night sky is not a picture of what is happening now. It is a museum of what has already happened, a collection of ancient photographs still hanging in the dark. Even here on Earth, the same principle is at work. The colours of a sunset are shaped by light that has spent minutes scattering through the atmosphere before reaching you. A rainbow is a conversation between sunlight and raindrops that began moments before you noticed it. The ripples on a lake surface carry the memory of a pebble's fall long after the pebble has sunk. Everywhere you look, you're witnessing delayed events, some by heartbeats, some by lifetimes, some by spans so vast that your entire species has risen and evolved in the time it took for that light to arrive. This delay is not a flaw or a trick, it is simply the way the universe works. Nothing moves faster than light, so every interaction is bound by this gentle rule of waiting. And because light, sound, and gravity all carry their history with them, we are constantly surrounded by reminders that the past is not gone in any absolute sense. It is flowing into the present all the time, in every direction. When you think about it this way, the present becomes less like a point on a line and more like a patchwork quilt. Some parts of it are stitched from things that happened a moment ago, others from events years or centuries in the past. What we call now is a blend, a carefully layered collage of moments arriving from all over the universe at once, and that means our everyday lives are lived inside a constant stream of time's echoes. It can be strangely comforting to realise this. The idea that the past is utterly gone can feel cold, like a door closing forever. But if the light from a star can still cross billions of years to reach you, then some part of the past is always finding its way forward. Even if we cannot return to it, we can still meet it here, in the space between one heartbeat and the next, in the thin gold of the afternoon sun, in the shimmer of starlight on a quiet night. As we move forward in this journey, we will explore what some scientists and philosophers have suggested about these layers of time, models where the past and present are not separate realms, but neighbours sharing the same vast landscape. For now, it is enough to stand here in this woven moment and listen to all the ages arriving together. If you could step outside of the universe, not just outside the Earth or the galaxy, but outside the entire framework of space and time, what would you see? It's a strange question, because stepping outside of time is something our minds can barely imagine. We're used to looking at space from a distance, seeing a whole city from the window of an airplane, or the curve of the Earth from a satellite. But what would it mean to see time from above, as though it were spread out in front of you? One of the boldest answers to that question is called the block universe. In this view, time is not a flowing river at all, but a solid landscape. Every moment that has ever happened, and every moment that will ever happen, is laid out together in a vast four-dimensional structure. Our past, our present, and our future are all part of the same block, like different rooms in a house. You do not destroy a room by walking out of it. It still exists. You're simply not in it anymore. To picture it more easily, think of a giant loaf of bread. Each slice is a single moment in the life of the universe. One slice contains you right now, listening to these words. The slices behind it contain yesterday, last year, the day you were born, and all the long centuries before that. The slices ahead hold tomorrow, next year, and every day until the very end of time. We move through these slices one by one, like a knife cutting steadily forward. But the rest of the loaf is still there, whether or not we're touching it. It's a comforting thought in some ways. The happy moments you've known, the laughter of a friend, the light of a warm morning, still have their own slices, quietly existing in the block. The sad and difficult moments are there too, but they are not chasing you. They are simply part of the shape of the whole. The block universe treats every instant as equally real. You may no longer be able to visit those moments, but they remain part of the cosmic architecture, as enduring as any mountain or ocean. Of course, our experience doesn't feel that way. We don't sense the rest of the loaf around us. We feel only the slice we're in, and we call it now. That is because, according to this idea, our consciousness is like a spotlight moving across the loaf, illuminating one thin slice at a time. What we think of as the flow of time is just the shifting of that light from one slice to the next. This model grew naturally from Einstein's theory of relativity. In relativity, there is no universal now, no single clock ticking the same for everyone, everywhere. Instead, each observer's sense of time is shaped by where they are and how they are moving. Events that seem simultaneous to one person may occur at different times for another. When you accept that simultaneity is relative, the idea of the block universe begins to feel less like science fiction and more like a natural consequence of physics. Some people find this unsettling because it challenges the idea of free will. If the future already exists somewhere in the loaf, are our choices just part of a story that has already been written? Others find it deeply reassuring. Nothing is truly lost. It's all still there, preserved in the structure of space-time. In this view, death is not an erasure, but simply a step into a different slice. The past remains, unchanging, like a photograph you can't pick up but know is still lying in the album. We can never step outside the loaf to see it whole, so we can't prove that this is how reality works. But the mathematics of relativity fits comfortably with this picture, and many physicists and philosophers see it as at least a useful metaphor. In daily life, we don't think of ourselves as walking through slices of time, but in a quiet way, we are. Each heartbeat a small step, each breath the turn of a page. There's a soft kind of beauty in imagining the universe this way. Picture the block not as something cold and rigid, but as a vast gallery of moments, each one containing all the light and sound and feeling it ever held. The moment when you learned to ride a bicycle, the moment when you first saw the ocean, the moment when you closed your eyes and listened to rain, all of them are still there, quietly shining in their own corners of the block. And somewhere, far ahead in the loaf, there is a moment you haven't met yet, waiting patiently for your spotlight to reach it. You don't know what it holds. You can't turn the pages out of order, but it is there, part of the same structure that holds this one. Whether or not the block universe is literally true, the idea itself can be a comfort, that time is not a thief carrying things away, but a library preserving them in a room you haven't yet learned to open. As we continue, we'll look at other ways of picturing time, some that agree with this gallery of slices and others that offer a very different vision. But for now, you can imagine yourself standing in a single, sunlit slice of a much larger loaf, feeling the weight of the rest of it around you, unseen but always present. If the block universe feels like one grand, unchanging structure where all moments stand side by side, then the next question is that the only way to think about time? The answer, as it often is in philosophy, is no. There are other pictures, softer, stranger, or more selective, that try to capture the nature of past, present, and future. 3 of the most discussed are known as presentism, eternalism, and the growing block view. Presentism begins from the idea that only the present moment is real. The past has already happened, and no longer exists. The future has not happened yet, and does not exist either. All that is truly there is the razor-thin instant we call now. It's a simple and intuitive view because it matches our everyday experience. The past is memory, the future is anticipation, and we live only in the present. In the presentist world, history is not something still lying behind us like pages in a closed book. It's more like a trail of footprints in sand that the tide has washed away. The marks they made are gone, except for the impressions they left in our memories, our records, and the lingering effects they have on what we see now. If you want an image for it, imagine standing on a train platform at night, watching the carriages pass. The one right in front of you is the present. The carriages that have already gone are nowhere to be found. They have rolled into darkness and disappeared. The ones that have not yet arrived are still far away, invisible. All you can truly touch is the carriage that is here in front of you now. Eternalism, by contrast, is the view that all moments in time, past, present, and future, are equally real. This is the philosophical cousin of the block universe model. According to eternalism, the moment you're listening to these words exists just as much as the moment when the first trees grew on Earth, and just as much as the moment when the last star in the universe will fade away. The difference is that you're not located in those other moments right now, just as you're not standing in another country this second. They exist, but they are elsewhere in the landscape of time. Eternalism can be a little dizzying to think about because it asks you to hold the idea that every event, your birth, the turning of a distant galaxy, the day a comet first brushed past the Earth, is equally solid in existence no matter when it happened or will happen. For some, that means the universe is like a vast library where all the books are on the shelves at once. You read one page at a time, but all the pages are already printed and none will be removed. Somewhere in between these two sites the growing block theory. In this view, the past and the present are both real, but the future does not exist yet. You can think of it as a train that has been steadily adding carriages as it moves. The ones behind you, the past, are still there. The one you're in, the present, is here with you now. But the carriages ahead, the future, haven't been built yet. The block of time grows as each new moment arrives, and nothing in the past is erased. The growing block model has a gentle appeal. It allows the comfort of knowing that the past is preserved, without having to imagine the future as fixed and unchangeable. In this picture, your choices still shape what comes next, because the future is an open space waiting to be filled in. It's like an artist painting a mural from one end to the other. The finished part behind them remains exactly as it is, while the blank wall ahead is still full of possibility. These three views, presentism, eternalism, and the growing block, are all ways of answering the same quiet question. What is real right now? Is reality a single moment, a complete block, or a block still being built? Physics alone does not settle the matter, because our equations work the same whether we treat past and future as equal partners or as passing shadows. The choice between them becomes, at least for now, a matter of perspective, one of those places where science and philosophy meet and find themselves sharing the same seat on the train. It's worth noting that each of these models shapes how we think about memory, loss, and hope. If you are a presentist, the past is gone, and your connection to it comes through what remains in the present. The photograph in your hand, the echo in your mind. If you are an eternalist, the past still exists in full, and perhaps you find comfort in imagining it attacked somewhere in the structure of time. If you lean toward the growing block, you may take heart in knowing that every moment you've lived is still part of the block, even as you step into the unknown of what comes next. None of these views has the final word, and maybe that's a gift. It means we are free to hold them gently, to move between them like walking through different rooms, seeing how each changes the way the light falls on the world. One might help you in moments of nostalgia, another in moments of decision, another in moments of grief. They are not so much rival truths as different windows, each opening on the same mysterious landscape. As we move into the next part, we'll take this landscape and tilt it slightly, to see what happens when we add the strange curves and distortions of Einstein's relativity. In that world, now becomes even less universal, and the map of time begins to stretch and bend in ways that make each observer's present uniquely their own. But before we get there, take a moment to notice the model of time that feels most natural to you. Are you drawn to the fleeting candle flame of presentism, the unbroken marble of eternalism, or the steadily building wall of the growing block? Whichever you choose, you can carry it with you as we step into relativity's more personal vision of the present. We have a habit of thinking that now is something absolute, a perfectly synchronized moment that exists everywhere, for everyone, all at once. If you imagine the world like a clock tower in a quiet village square, it feels as if every person, every street, every house is sharing the same chime of the bell. The second hand ticks, and the whole universe steps forward together. That sense of a shared, universal now is so deeply rooted in how we live that we rarely stop to question it. But Einstein did. In his theory of relativity, time is not a master clock keeping the same beat for everyone. Instead, time is part of the flexible fabric of the universe, intertwined with space, stretching and bending under the influence of motion and gravity. When you move quickly, or stand in a different gravitational field, your clock runs differently from someone else's. And because of this, the idea of the universal present, one now that applies to every point in the cosmos, quietly unravels. To picture this, imagine shining a flashlight in a dark room. The beam doesn't fill the whole space at once. It spreads outward at a fixed speed, touching some places sooner and others later. In relativity, your now is like that beam. The events that fall inside its reach are the ones you can meaningfully call part of your present. Anything outside that cone of light, whether it's too far away or moving differently enough, belongs to a different now. Physicists often talk about this in terms of light cones. A light cone is a map of what events you can influence or be influenced by based on the speed of light. Inside your light cone is the set of events that share a possible connection with you, things you could reach with a message, or that could reach you. Outside the cone are events that are simply too far or too differently arranged in space-time for your present to touch them. To someone else, moving at a different speed or standing in a stronger gravitational field, that cone tilts and shifts. Their now overlaps with yours only partly. This means that two people in different places, moving in different ways, can honestly disagree about whether two events happened at the same time, and both would be correct in their own frame of reference. For someone standing on Earth, a star might explode now, while for someone speeding past that star in a spacecraft, the explosion might already have happened or be yet to come. Time itself bends to their paths. The idea can feel unsettling at first, because it means there is no single cosmic metronome ticking away the moments. But it also opens up a gentler, more personal view of time. Your present is not a rigid shared moment. It is a little patch of space-time that travels with you, shaped by where you are and how you move. In that sense, now becomes something intimate, almost private, your own small window onto the vastness of the universe. Even here on Earth, relativity is at work, though we usually only notice it in precise measurements. The clocks on GPS satellites tick slightly faster than the clocks on the ground because the satellites are farther from Earth's gravity. Engineers must correct for this difference so that your phone can tell you where you are. Without that tiny adjustment, just billionths of a second each day, GPS would drift, and within a couple of minutes it could be off by kilometers. These adjustments are not just quirks of machinery, they are the fingerprints of relativity, written into the technology we use every day. The deeper you go into this idea, the more the concept of a single, universal present dissolves. Instead of one great cosmic moment, there are countless overlapping nows, each carried by an observer through their path in space-time. Some of these nows intersect, allowing shared experiences and synchronized events. Others are tilted so far apart that they may never touch. The universe becomes less like a single stage, where everyone stands together, and more like a web of moving platforms, each with its own rhythm and view. And yet, this is not a lonely picture. If anything, it can be a comforting one. It means that your moment, right now, is truly yours. It's stitched from the light that has reached you, the gravity that holds you, and the movement you've made through space. No one else's now is exactly the same, though they may overlap with yours in beautiful ways: a shared meal, a quiet conversation, a look at the same rising moon. Relativity doesn't erase the sense of a shared life. It simply reminds us that our shared life is a patchwork of many personal times, carefully sewn together. The thread that binds them is light itself, carrying signals from one frame to another, allowing your present to touch someone else's, even across vast distances. So when you think of now, from here on, you can imagine it as a small, softly glowing bubble moving with you, shaped by your path through the universe. Other bubbles float nearby, some brushing against yours, some drifting apart. There is no great bell ringing for all at once, but there are countless quiet chimes, each marking a moment that is, in its own frame, exactly now. In the sessions ahead, we will step away from the abstract models and follow the messengers that connect these nows. Beams of light, ripples in space-time, and echoes from the ancient past. They are the threads that weave personal time into the vast fabric, and in following them, we may see more clearly how the past is never truly gone, only drifting just outside our own shimmering present. If the universe has a preferred language, one it has been speaking for almost 14 billion years, it is the language of light. Everything we know about distant stars, galaxies, and even the shape of the cosmos itself comes to us in this language, sometimes in brilliant bursts, sometimes in faint whispers that take enormous effort to hear. Light is a messenger unlike any other. It doesn't just tell us where something is, it tells us where something was. The reason is simple, yet quietly profound. Light travels at a finite speed. In the emptiness of space, it moves faster than anything else we know, but still it takes time to cross distance. The sunlight warming your hand left the sun a little over 8 minutes ago. The light from the nearest star beyond the sun began its journey more than 4 years ago. And the light from some galaxies we can see tonight started its trip toward us, billions of years before there were human eyes to greet it. This means that whenever you look at anything, a candle flame across the table, the moon hanging in the night sky, the glow of a galaxy in a telescope, you are looking at the past. Every photon that reaches you has been travelling since the moment it left its source, carrying the shape and colour and energy of that instant. It is like a postcard that has taken a particular route through space, arriving long after the scene it depicts has changed. On Earth, the distances are short enough that we hardly notice the delay. The glow from a street lamp reaches you in less than a millionth of a second. The light reflected from your friend's face in conversation takes only tiny fractions of a second to arrive. The lag is invisible to your senses, but once you start looking beyond our small, shared patch of the universe, the travel time becomes impossible to ignore. Astronomers live with this delay every day. Their work is not to see the universe as it is now, but as it was when the light began its journey. That's why looking deeper into space is also looking deeper into time. A telescope trained on a galaxy a billion light years away is seeing that galaxy as it was when the Earth's continents were still in different places, when forests of giant ferns covered the land, and when the first mammals were tiny creatures hiding in the underbrush. The galaxy may look calm and beautiful in the image, but in our present moment, it could be wildly different, full of new stars or darkened after their deaths. The light simply hasn't had time to bring us the news, It's not only distant starlight that works this way. Light from our own planet's past is also out there, still travelling. Photons that bounced off the oceans centuries ago have left Earth entirely, continuing into space in all directions. Most of them will wander forever without ever being intercepted, but a few might someday strike the surface of a far-off world, where an observer could study them and see faintly the shimmer of sunlight on our seas. In that sense, every planet, moon and rock is constantly shedding images of itself into the universe, a steady broadcast of its own history. The path of light is not always straight and simple. Along the way, it can be bent by gravity, scattered by dust, or absorbed and re-emitted in different colours. Yet through all of this, it still carries information about where and when it came from. A beam of light from a distant quasar can tell us not only how bright that quasar was billions of years ago, but also what gases lay between it and us, and how those gases moved. Light is more than a courier. It is a letter that describes not just the sender, but the whole journey. There is something gentle in this idea, that the universe keeps sending us pieces of its memory, one photon at a time. You could sit quietly under a dark sky and know that the faintest glimmer you see has travelled across unimaginable distances to arrive in your eyes. Some of those journeys began when the first flowers bloomed on Earth. Some began when there was nothing here but molten rock. A few began before our planet even existed, when the sun itself was still just a cloud of gas in the galaxy's spiral arm. Light's constancy also makes it a perfect clock. Because its speed never changes in a vacuum, we can measure how far it has travelled by how long it took to get here. Astronomers use this fact to map the universe like archivists sorting shelves by age, the closer galaxies on one side, the older, more distant ones on another. The oldest light of all, which we'll visit later, comes from a time when the universe was less than 400,000 years old. In cosmic terms, that is the baby picture still framed in the hallway, a reminder of beginnings we can only imagine. And so, light becomes our first and most faithful time machine. It is not one we can climb into and use to visit the past, but one that visits us every moment of every day, carrying pieces of the past into our present. It tells us stories in a language we have learned to read with our instruments, our theories, and our own eyes. And though the stories are incomplete, each a single frozen moment from long ago, together they form the great patchwork of the universe's history. When you look at the stars tonight, you can think of them as postcards still arriving from across the ages. Some were sent when dinosaurs walked the earth, others were sent before there was any life here at all, and all of them, whether from across the street or across the universe, are messengers with the same quiet message. I was here. I shone. I am still on my way to you. In the next session, we'll see how light doesn't always arrive just once. Sometimes it takes a longer path, bouncing off clouds of dust or gas, arriving years or even centuries after the original flash. These light echoes are the universe's replays, allowing us to watch ancient events unfold again, long after they first happened. Light usually takes the most direct path it can. It leaves its source and travels outward, straight as a stretched string, until it meets something that stops it, bends it, or scatters it aside. But sometimes, a portion of that light takes a longer, more winding journey. It might brush past dust floating between the stars, or bounce off clouds of gas, taking a detour before finding its way to us. And when that happens, it can arrive years, even centuries, after the original flash, carrying the memory of an event we thought had gone dark. This is what astronomers call a light echo. The name is perfect, because the process is so much like sound in a canyon. Shout toward the cliffs, and you will hear your own voice return, delayed and softened, shaped by the surface it touched along the way. In space, the shouting is an intense burst of light, a supernova, a flare from a star, a sudden brightening of a galaxy's core. The cliffs are clouds of cosmic dust, grains smaller than smoke particles drifting quietly in the dark. When the light hits them, a small portion is scattered in a new direction, and if that new path happens to lead toward Earth, we see the event play again, as if the universe has given us a second showing. One of the most famous examples is tied to Tycho's supernova, which exploded in 1572 in our own galaxy. It was bright enough to be seen during the day, startling people across Europe and Asia who had never witnessed a new star suddenly appear in the sky. Astronomers of the time could only watch as it slowly faded over the next year, knowing that once the light was gone, the event itself would vanish into history. And yet, centuries later, telescopes caught something remarkable. Faint patches of light in surrounding clouds of dust, the scattered remnants of the original flash. By studying these light echoes, modern astronomers could effectively watch the supernova unfold again, hundreds of years after its first performance. It is as if the universe recorded the event without meaning to, storing it in the surrounding material, waiting for the right angle to play it back. Light echoes let us recover details that would otherwise be lost forever. The chemical signature of the explosion, the pattern of its rise and fade, even clues about what kind of star it once was. All of that is wrapped up in the photons still making their way to us, long after the main event has passed. The idea is strangely comforting. When we think of the past, we often picture it as a closed door. What has happened is gone, locked away. But a light echo is a reminder that the past sometimes lingers in unexpected places, waiting to be noticed. The light doesn't care whether centuries have passed. It simply follows the path laid out by physics, arriving when and where it can. In a more personal way, you can see light echoes every day. Look at the evening clouds glowing in shades of orange and pink. That is sunlight scattered by air and dust, arriving at your eyes on a path far less direct than the noon suns. The shimmer of light on a lake is a series of tiny echoes, each reflection a new version of the same light, delayed by the time it takes to reach you. These earthly echoes are short-lived, but they work on the same principle. In deep space, the scale is much larger. A light echo might travel for hundreds or thousands of years before it reaches us. And unlike sound echoes, which fade quickly, light echoes can remain sharp enough for us to measure and analyze. They give astronomers something precious, the ability to study cosmic events long after the main light has passed by. Some scientists have even suggested that our own galaxy could be filled with hidden light echoes, especially from bright flares and supernovae in its past. With sensitive enough instruments, we might be able to map these echoes, piecing together a moving picture of the Milky Way's history. It would be like walking through an ancient hall and finding that the walls still glow faintly with scenes from centuries ago. There is poetry in the idea that light can take more than one path, that it can arrive late and still have a story to tell. It means the universe is full of second chances, not for the events themselves, which unfold only once, but for us to witness and understand them. It's a reminder that our knowledge is not limited to what happens while we are watching. Sometimes the cosmos holds on to its own memories, letting them drift back to us, across time. If you stand outside on a crisp night and look up, you might imagine that some of the starlight you see is already an echo, not the first light from that star, but a delayed glimmer sent by a longer path. You would have no way to tell, just as you can't distinguish the first call in a canyon from the echo that follows without knowing the terrain. And maybe that's part of the magic. Light echoes are a quiet reminder that the universe doesn't always reveal itself all at once. Sometimes it waits, and then, in an unhurried way, lets us see the same beauty twice. In the next session, we'll move from light's gentle delays to something even stranger, ripples in the very fabric of space-time itself. These are not echoes in light or sound, but in the shape of reality, travelling outward from violent events in the distant past. We'll listen for them the way you might listen for the faint tremor of a pond surface long after the stone has sunk. If light is the universe's messenger in colour and brightness, then gravitational waves are its messengers in rhythm. They are not made of particles streaming through space. They are waves in space itself, ripples in the very fabric of reality. Imagine space and time together as a vast taut sheet. Now imagine something heavy and restless moving across it. If that motion is gentle, the sheet hardly stirs. But when masses truly collide or dance together with great violence, the sheet shivers. Those shivers spread outward as gravitational waves, carrying with them the memory of what caused them. The idea first appeared in Einstein's general theory of relativity in 1916. According to his equations, whenever a massive object accelerates, like two stars orbiting one another, it should send out waves in space-time. But those waves are so incredibly weak that for decades, most scientists doubted we would ever detect them directly. The universe is vast, and the stretching and squeezing of space these waves cause is smaller than a fraction of the width of an atom by the time they reach us. Yet the waves are patient. They travel at the speed of light, unimpeded by gas, dust, or magnetic fields. Unlike light, which can be blocked or scattered, gravitational waves pass straight through anything in their path. That means they carry pristine information from places light can never escape, the very hearts of collisions between black holes, or the dense, tangled cores of exploding stars. Think of tossing a stone into a perfectly still pond. The ripples move outward in smooth, expanding circles, carrying the signature of that single splash. In the cosmos, the stones are things like two neutron stars spiraling together, or two black holes merging into one. The ripples they send out are not on the surface of water, but in the structure of space and time itself. And if we are patient and sensitive enough, we can feel them. That patience finally paid off in 2015, when the Laser Interferometer Gravitational Wave Observatory, better known as LIGO, made the first direct detection of gravitational waves. It was a faint rising chirp in the data lasting just a fraction of a second. But encoded in that brief signal was the story of two black holes, each about 30 times the mass of the Sun, colliding more than 1 billion light-years away. By the time the waves reached Earth, they had been travelling for over 1 billion years, ripples from an event that happened before the first flowers bloomed on our planet. The technology behind detecting them is delicate almost beyond belief. LIGO and its European counterpart, Virgo, use long tunnels with mirrors at each end, measuring tiny changes in the length of those tunnels as gravitational waves stretch and squeeze space. The change is so small that if you scaled up the tunnel to the distance between the Earth and the Sun, the shift would be less than the width of a human hair. And yet, these instruments can feel it. Since that first detection, dozens more events have been recorded. Black holes merging, neutron stars colliding, and in one remarkable case, the collision of two neutron stars that also produced a burst of light. That event let astronomers watch both kinds of messengers, light and gravitational waves, arriving from the same source, each telling a different part of the story. What makes gravitational waves so special is that they are not just signals from the past, they are unfiltered signals. Light from a distant event can be absorbed, re-emitted, distorted, and delayed. Gravitational waves pass through the intervening universe unchanged, preserving the exact rhythm of the dance that created them. In this way, they are pure time capsules. The shape of the wave you detect now is the same as it was when it first left its source. There is a quiet poetry in knowing that these waves wash over us all the time. Most are too faint for our detectors to notice, but they are there, passing through your body, through the walls of your home, through the Earth itself, stretching and squeezing space in ways so small that you cannot feel them. They are constant reminders that the universe is not a still stage, but a restless, shifting fabric, alive with the memory of its own events. And just as with light, the distance a gravitational wave has travelled tells you how far back in time you are listening. A wave arriving tonight from two black holes that merged 5 billion light-years away is a direct message from a past when the Earth was just beginning to form its first continents. You cannot go to that time, but you can hear it. In a sense, the wave is the event still moving through the universe, still reshaping the space it passes. The more sensitive our detectors become, the more of these faint signals we will catch. One day, we may even be able to hear the gravitational waves from the moment the first black holes formed, or from the very first fraction of a second after the Big Bang. Those would not just be echoes from the past, they would be the oldest songs the universe has ever sung. For now, each detection is like hearing a knock on a door from very far away. You know the sound started long ago, but the pattern of it, the energy of it, still carries the identity of the one who knocked. Black holes, neutron stars, supernovae, each has its own rhythm. And in learning to listen, we are learning not just about these events, but about time itself, written in the slow swell and fade of space-time's own music. In the next session, we will step even further back, to the faintest light of all, still travelling toward us from nearly the dawn of the universe. It is the cosmic microwave background, the first glow of a cosmos just beginning to take shape, and it is the oldest photograph we will ever see. There is light in the universe that has been travelling for almost as long as the universe has existed. It began its journey more than 13.7 billion years ago, when the cosmos itself was only a few 100,000 years old, a newborn in cosmic terms, just beginning to settle into its shape. This light has been on the move ever since, crossing expanding space, growing fainter and cooler with every passing eon. And yet, it is still here, arriving from every direction at once, washing over the Earth in a constant invisible glow. We call it the cosmic microwave background, or CMB for short, and it is the oldest photograph we will ever have of the universe. To understand where it came from, you have to picture the universe in its earliest days, a hot, dense soup of particles so energetic that atoms could not yet form. Photons, the particles of light, bounced endlessly off electrons and protons, unable to travel more than the smallest fraction of a millimetre before scattering. The cosmos was not dark, but neither was it transparent. It was like standing inside a glowing fog. Light was everywhere, but it could not travel freely. As the universe expanded, it cooled. Eventually it reached a point about 380,000 years after the Big Bang, when the temperature had dropped enough for electrons and protons to combine into neutral atoms. Suddenly the fog lifted. Photons were free to travel without constant collisions, and in that moment the universe let out its first clear light. Those photons have been travelling ever since, stretching with the expansion of space itself. Today that ancient light has cooled so much that it is no longer visible to our eyes. It has shifted into the microwave part of the spectrum, a faint afterglow that sensitive instruments can detect. If our eyes could see microwaves, the night sky would never be truly dark. It would be filled with a uniform, soft background glow, a reminder of the universe's earliest breath. The discovery of the CMB was almost accidental. In 1965, two radio engineers, Arno Penzias and Robert Wilson, were testing a large antenna in New Jersey. No matter what they did, they kept picking up a faint, persistent hiss in their measurements. They cleaned the equipment, they checked for interference from nearby cities, they even removed a nest of pigeons and cleaned away the droppings inside the antenna. But the hiss remained. Eventually they realised they were hearing the universe itself, the cosmic microwave background, arriving from every direction, the same no matter where they pointed their instrument. Without meaning to, they had tuned into the afterglow of creation. Since then, more precise measurements have revealed that the CMB is not perfectly smooth. It has tiny variations in temperature, differences of just a few millionths of a degree, that mark places where the young universe was slightly denser or thinner. These variations are like the seeds of all future structure. Galaxies, stars, planets, and everything we see today grew from those subtle imbalances. By mapping them, scientists can learn about the age, shape, and composition of the universe, and even glimpse hints about what might have happened in the very first fractions of a second after the Big Bang. Satellites like COBE, MAP and Planck have turned the CMB into a kind of cosmic wallpaper, a map of the whole sky that looks almost like a speckled pattern in shades of blue, yellow and red. Each speck represents a difference in temperature, a whisper from the infant universe about the way matter and energy were distributed at the beginning. It is a map not of where things are now, but of where they began. There's a deep stillness in imagining those photons travelling across space for nearly 14 billion years, never stopping, never turning back, just moving outward in all directions. Some of them have passed through regions of the universe that will never form galaxies. Some have skimmed the edges of clusters of galaxies, their paths bent slightly by gravity. But all of them carry the imprint of that first great clearing of the cosmic fog. When we detect the CMB today, we're not just looking far into space, we are looking far into time, to an era so remote that no human mind can truly picture it. The Earth did not exist. The Sun had not yet formed. Even the oldest stars we know today were still billions of years in the future. And yet, the light from that time is here, falling quietly onto our detectors, telling us in its own way, I was there when it all began. It is tempting to call the CMB a relic, as if it were something the universe left behind, but in truth, it is still part of the present. Those photons are arriving right now, and they will keep arriving for as long as space continues to expand. Every second, trillions of them pass through you, unnoticed, as constant and quiet as breath. The CMB is not only a message from the past, it is an ongoing connection to it, woven into the fabric of reality itself. There's also a certain humility in the fact that we can't see it directly. The most ancient light in the universe is invisible to our eyes, and yet we know it's there. It's a reminder that much of reality exists outside our senses, waiting for us to build the tools to notice it. And when we do, it changes not only our understanding of the cosmos, but our place within it. In the next part of our journey, we'll step away from the grand scale of the universe's first light and return to something closer to home, the ways in which the past is preserved here on Earth, in fossils, in tree rings, and in the atoms that make up our own bodies. Because sometimes the story of time's persistence is not written across billions of light years, but right beneath our feet, or within our cells. There is a strange promise whispered by the mathematics of quantum mechanics, a promise that nothing, not even the smallest detail, can ever be truly lost. It is a statement that sounds simple enough, but the more you think about it, the more it changes the way you picture the past. In classical life, we're used to things vanishing. You burn a letter and the words are gone. You erase chalk from a blackboard and the writing disappears. You whisper a sentence in an empty room and the air swallows the sound. We treat the past as something fragile, easy to erase, impossible to retrieve once it's gone. Quantum theory tells a different story. In its equations, the information describing a system, the precise state of every particle, is never truly destroyed. It can change shape, scatter into complexity beyond comprehension, become tangled with the states of other particles, but it is always there, somewhere, in some form. The universe, it seems, is an immaculate record keeper, refusing to crumple its pages into nothing. The idea is often explained with an image. Take a piece of paper and write something on it. Now crumple it into a tight ball. The words are no longer visible, the neat arrangement of ink and fibres hidden in folds and creases. But if you had infinite patience and skill, you could, in theory, unfold the paper, smooth it out, and read what was written. In quantum mechanics, the paper is the state of the universe, and the crumpling is the unfolding of events. The message might be scattered into the positions and motions of countless particles, far beyond our ability to track, but it is still there. This isn't to say we could ever recover the full details of the past in practice. Even the tiniest speck of dust contains more quantum information than any computer we could build in the foreseeable future. But the principle is important, because it means that, at the deepest level, the past doesn't vanish the way we imagine. It sinks into the structure of reality, woven into the states of particles and fields, hidden in patterns we cannot untangle. In everyday life, we can glimpse hints of this persistence. A fossilized leaf in stone still carries the delicate veins of its original form, even though the living tissue has long been replaced by minerals. The grooves in an old record hold the exact path a needle once traced to bring a song to life. The DNA in your cells carries sequences inherited from ancestors who lived hundreds of thousands of years ago. These are the macroscopic echoes of the quantum truth, that every change leaves traces, however faint. On the smallest scales, quantum mechanics describes particles not as tiny billiard balls, but as waves of probability, constantly interfering and overlapping. When they interact, their states become entangled, meaning the details of one are woven into the details of another. Even if they later drift apart across light years of space, the connection remains. This entanglement is part of the reason the past cannot be fully erased. To erase it, you would have to sever every one of these subtle threads, and the laws of quantum mechanics forbid it. It is a comforting and unsettling thought at the same time. Comforting, because it suggests that nothing we do is ever truly gone from the universe's memory. Unsettling, because it means that the universe remembers everything, whether we want it to or not. The laughter in a room, the fall of a raindrop, the flare of a distant star, each becomes part of a vast interwoven record, forever out of reach, yet forever real. Physicists call this principle unitarity. It is the rule that the evolution of a quantum system preserves the total information, no matter how scrambled it becomes. Unitarity is what allows quantum mechanics to be reversible in theory. If you had the exact state of everything in the universe at one moment, you could run the equations backward and reconstruct what came before. In practice, of course, the sheer complexity makes this impossible. The number of variables is so unimaginably large that even the best simulations can only capture a fragment. Still, the principle stands, like a quiet law written at the base of reality. And so, in the quantum view, the past is not a ghost that fades. It is a crumpled page still tucked somewhere in the folds of the universe. We may never read it again, but we can be certain it exists. Even the oldest events, the flicker of light from the first stars, the collisions of particles in the universe's first second, are still there, imprinted in the quantum state of things just beyond our reach. It changes the way you think about time. We often imagine the present as replacing the past, sweeping it away with each passing second. But perhaps the present is simply a new layer added to an ever-growing archive, the past still intact beneath it. The layers mingle and influence one another in ways we can't see, like ink bleeding faintly through the pages of a thick book. In the sessions ahead, we'll meet some of the experiments that have tested these strange ideas. Some of them go further still, suggesting that our choices in the present can affect how the past appears, not by changing it, but by deciding which version of it becomes real to us. These experiments hint at an even stranger truth, that the past is not fixed in the way we imagine, but is instead a set of possibilities, only one of which becomes the story we tell ourselves. For now, it is enough to sit with this image, the past crumpled but never discarded, tucked into the folds of the universe. It is there in every particle, every ripple, every faint vibration of the quantum world. It does not fade, only hides, waiting in patterns we may never fully read, but that nonetheless shape the world we live in now. In most of our everyday experience, the past feels like a completed chapter. Once something has happened, it is fixed. The ink has dried, the moment is sealed. You can describe it, you can remember it, but you cannot change it. The flow of cause and effect feels one way. What you do now might shape the future, but it should not alter what has already occurred. Yet in the strange theatre of quantum mechanics, there are experiments that seem to bend this comfortable rule. One of the most puzzling among them is called the delayed choice experiment, and it plays with the boundaries of time in a way that feels almost mischievous. It begins with an older puzzle, the famous double-slit experiment. Imagine a beam of light aimed at a barrier with two narrow openings. If you place a detector behind the barrier and keep both slits open, the light doesn't just form two bright patches as you might expect. Instead, it creates an interference pattern, alternating light and dark bands, as though the light has behaved like a wave, passing through both slits at once and interfering with itself. But if you place detectors at the slits to check which one the light actually went through, the pattern changes. Now the light behaves like particles, choosing one slit or the other, and the interference pattern disappears. The mere act of measuring changes the outcome. This is already strange enough, but the delayed choice version takes it further. In this variation, you don't decide whether to measure the path until after the light has passed through the slits, or in some setups, even after it has hit the final detector. And still, the result behaves as though the choice you made in the present somehow influenced whether the light took one path or both in the past. The effect can be described without invoking time travel. In quantum mechanics, until a measurement is made, the system exists in a state of possibilities, a superposition. The measurement doesn't reach back and change history, it simply determines which history becomes part of the record. But the human mind, so used to a fixed past, can't help but feel the strangeness of it. It's like opening a sealed letter and finding that the words seem to have been chosen in response to your mood at that exact moment, even though the letter was written long ago. John Archibald Wheeler, the physicist who proposed the delayed choice experiment, liked to use a cosmic scale analogy. Imagine a quasar, a bright distant galaxy with a feeding black hole at its centre, shining light toward Earth from billions of light years away. Between us and the quasar lies a massive galaxy whose gravity can bend the light, sending it toward us along two different paths, like a giant natural lens. In Wheeler's thought experiment, astronomers could choose to set up their instruments in a way that reveals which path the light took, or in a way that lets the two paths interfere like waves. And crucially, they could make this choice now, billions of years after the light left the quasar. Depending on the choice, the experiment would reveal either a particle-like path or a wave-like interference, as though the light's decision about how to travel was not made until the moment of measurement, here on Earth. No one seriously believes this means we are rewriting cosmic history, but it does challenge the idea of a neatly ordered timeline in which the past is fully independent of the present. In the quantum picture, what we call the past may be more like a set of overlapping drafts, only one of which becomes the official version when an observation is made. This is unsettling if you want the past to be solid and unchangeable. It is also strangely beautiful. It suggests that reality is not a single frozen reel of film running from start to finish, but more like a living performance, with some parts scripted and others waiting to be decided in the moment. You can find gentler analogies in everyday life, though none match the precision of the quantum world. Imagine reading a mystery novel in which the identity of the culprit is not fixed until you reach the final chapter. Or imagine a path through the woods that branches in several places, but only solidifies under your feet as you walk it. In these analogies, nothing changes retroactively. Rather, the past was never a single path to begin with. It was a cloud of possibilities waiting for your choice to narrow it. The delayed choice experiment is one of those reminders that the way the world works on the smaller scales is not the way it feels to us as human beings. We live in the macroscopic world, where cause and effect seem clean and linear, and where the past feels settled. But beneath that surface, in the quantum fabric, events can remain suspended between possibilities until the very last moment, and perhaps even beyond. In the context of our journey through time, This means that the past we imagine as locked away may be more fluid than we think, not in a way that lets us change it at will, but in a way that reveals its hidden potential. The universe may keep its options open longer than we expect, holding the past in a soft, unfixed state until reality has no choice but to settle it. In the next session, we will explore a place where this idea collides with one of the most extreme environments in the cosmos, the inside of a black hole. There, questions about whether information can be lost or preserved become more than thought experiments. They become puzzles at the edge of physics itself, where the past, present, and future may all blur into something we can only begin to imagine. Imagine a room with no windows and a single heavy door that locks from the outside. Once something is placed inside and the door is shut, nothing ever comes out again. You could place a candle in the room and wait 100 years. No light would leak through. You could throw in a chest of letters, a painting, a box of photographs, and never see them again. You might even forget what you put inside. The room becomes a sealed place, a private corner of reality cut off from the rest. For a long time, this was how physicists thought about black holes. They were places where matter, and the information it carried, could fall in but never escape. The intense gravity would pull everything inward, compressing it beyond recognition, hiding it forever from the rest of the universe behind an invisible boundary called the event horizon. And then came the paradox. Stephen Hawking, in the 1970s, discovered that black holes are not completely black. Quantum effects near the event horizon cause them to emit a faint glow, now called Hawking radiation. Over immense spans of time, this radiation can cause a black hole to lose mass and eventually evaporate entirely. That was surprising enough, but it led to an even stranger problem. If a black hole truly disappears, what happens to the information about everything it swallowed? According to quantum mechanics, information can never be destroyed, not the complete microscopic details of a system's state. But if Hawking's evaporation process really erases that information, the basic rules of physics are broken. This is the black hole information paradox, a tension between the laws of quantum theory and the predictions of general relativity. One way to picture the problem is to think of burning a book. The words may be scrambled into smoke, ash, and heat, but if you could track every molecule and photon in perfect detail, you could, in principle, reconstruct the original text. With a black hole, it seems different. When it vanishes, all you have left is featureless radiation, like a fire that leaves not even ash behind, only a faint scent in the air, and even that fading. The question is whether that scent contains all the subtle details needed to recreate what was lost. Some physicists argue that the information must be encoded in the Hawking radiation itself, not in a way we can easily read, but hidden in correlations between the emitted particles. In this view, the radiation is like an intricate code, preserving the details of what fell in, though scattered beyond comprehension. Others have proposed that the information might be stored on the event horizon itself, in a kind of two-dimensional imprint of everything inside, an idea connected to the holographic principle, which suggests that the volume of space can be described by information on its boundary. There are even wilder possibilities, that black holes might be connected to other regions of space and time through wormholes, allowing information to leak out in ways we can't yet detect, or that space-time itself subtly reshapes around them, preventing true loss from ever occurring. Whatever the answer, the paradox forces us to confront a deeper question. If black holes really do keep some record of everything they've consumed, then the past they contain is not gone. It is preserved in a form we can't access, like a memory that belongs only to the universe itself. And if they truly erase information, then we may have to rethink the very foundations of physics. For all their strangeness, black holes are part of a larger pattern we've seen throughout our journey, the past clinging to existence in unexpected ways. Light carries ancient images, gravitational waves carry ancient motions. the CMB carries the first glow, and perhaps, in the ultimate vaults of space-time, black holes carry histories we may never read. It is also worth remembering that black holes are not only destructive, they are dynamic objects shaping galaxies, influencing the formation of stars and stirring the environments around them into extreme beauty. Even the Hawking radiation, if it truly exists as predicted, is a gentle form of release, a slow return of energy and matter to the wider universe. If information is indeed encoded in it, then a black hole's final moments are not an act of destruction, but a long and silent unspooling of everything it ever contained. You could think of it as a story told in reverse, a library whose books vanish from the shelves one by one, but whose words are whispered into the air in a language no one yet understands. The books are gone, the shelves are bare, but in the quiet hum of particles the sentences may still be there. The black hole information paradox remains unsolved. Decades of debate have produced compelling arguments, but no consensus. Perhaps the answer will require a new theory that unites quantum mechanics and gravity, a theory in which space, time and information are woven together so tightly that the loss of one is impossible without the loss of all. Or perhaps the solution will be as strange and unexpected as the paradox itself. For now, black holes remain both a challenge and an invitation, a reminder that the universe holds on to some of its secrets not to frustrate us, but to remind us that the story is not yet finished. The past, in whatever form it takes, may be safer than we think, even in the most extreme corners of reality. In the next session, we will turn to an even broader question. What if time itself is not a fundamental ingredient of the universe, but something that emerges from deeper laws? If that is true, then the past, present and future may not be different places at all, only different patterns in the same endless weave. We tend to think of time as something absolute, as if it were a river flowing steadily past us whether or not we notice it. We picture it as a background stage on which the events of the universe play out, indifferent to what happens on it. But in the last few decades, some physicists have begun to ask a surprising question. What if time is not fundamental at all? What if it is something that emerges from deeper structures, something woven out of the way the universe stores and shares information? It is not the first time our sense of reality has been overturned. Once we thought heat was a basic quality of matter, until we learned it emerges from the collective motion of particles. Once we thought solidity was a simple fact, until we learned that most of an atom is empty space. Time, too, might be like that. Not a basic ingredient, but a pattern that forms when certain conditions are met. In some of these ideas, time arises from the quantum entanglement between particles. Entanglement, as we've seen, is a kind of invisible stitching that links the states of particles across space. Imagine the universe as a vast fabric of such stitches. When enough of them connect in certain ways, a sense of sequence emerges, a before and after a flow. But remove the stitches, and the distinction between past, present and future may fade, like colours bleeding together when the weave loosens. One picture is to imagine a tapestry. From a distance it shows a clear scene, a landscape, a figure, a path winding toward a horizon. That's the time we experience. But if you press your eye close to the threads, the image dissolves into tiny knots and fibres, each connected to others in intricate ways. The picture is not painted on the fabric, it is the fabric. Time, in this view, is the large-scale pattern of countless quantum threads. This way of thinking changes the status of the past. If time is emergent, the past is not a place we have left behind, but a structure still woven into the fabric. The pattern may shift, threads may loosen or tighten, but nothing is ever truly removed. The earlier parts of the tapestry still exist in the weave, even if we're no longer focused on them. There are hints of this in certain approaches to quantum gravity, the still elusive theory that would merge general relativity with quantum mechanics. Some models suggest that space-time itself may be built from networks of relationships between events, rather than from a smooth, continuous background. In these models, what we perceive as the flow of time could simply be the way our consciousness moves through this network, tracing a path that feels like a forward journey. It is an unsettling idea, because it suggests that time might not exist in the absence of observers or systems capable of recording change. Without the weaving of states into patterns, there might be no before or after, only an unstructured sea of possibilities. The past would still be there in potential, but it would not be separated from the present or future in the way we're used to imagining. And yet, this view is strangely comforting in the context of our question about whether the past disappears. If time is emergent, then the past is not a fragile thing receding into nothingness. It is part of the same underlying structure that holds the present together. You do not move away from it, you move across it, along a path that reveals one part of the weave at a time. Think of a book. The story feels as though it unfolds page by page, but all the pages already exist. The ending is there before you arrive at it. The beginning does not vanish when you turn the page. You simply experience the pages in a sequence, while the book as a whole exists all at once. In the emergent view of time, the universe might be like that, except that the pages are not fixed in ink, but written in the subtle language of quantum states, constantly influencing one another. There is also a hint here of why different observers might experience different nows, as relativity tells us they do. If time is not a universal river but a path traced through the weave, then each path might reveal a different cross-section of the pattern. Your now might include threads that are part of someone else's past or future. The fabric holds them all. The difference is only in the slice you're looking at. These are ideas still in their infancy, and they may never lead to a complete theory, but they offer a way to imagine the persistence of the past without requiring that we could ever travel back to it. It is not a lost country or a vanished shadow. It is part of the deep structure of reality, inseparable from the present, waiting quietly in the weave. In this sense, the past has not gone anywhere. It is simply not the part of the pattern you are standing in. The warmth of a childhood memory, the first breath of air you ever took, the glint of sunlight on an ancient sea, all of it may still be here, embedded in the quantum connections that give rise to time itself. In the next part of our journey, we will step away from the most abstract theories and return to the evidence we can touch, measure, and see. The traces of the past preserved in the natural world, in the shapes of landscapes, the layers of ice, and the patterns written into living things. These are the earthbound archives of time, and they remind us that, however strange the physics may become, we already live surrounded by pieces of history. If you know how to look, the Earth will show you its memory. It doesn't keep it in books or on shelves, but in layers of stone, in the quiet circles of a tree's heartwood, in the deep ice that sleeps under mountains of snow. These are the planet's diaries, patient, unhurried, written in an alphabet of minerals, growth and preservation. Take a tree, for example. To most of us, its surface changes with the seasons. A flush of green in spring, deep shade in summer, gold and fire in autumn, bare branches in winter. But inside the trunk, something more lasting is being written. Each year, a new ring forms under the bark, recording the pace of that year's growth. A wide ring speaks of abundance, warm temperatures, plentiful rain. A narrow ring tells of drought or a harsh winter. Over decades, these rings become a silent autobiography, a history of weather and change rooted in one spot. Dendrochronologists, scientists who study tree rings, can read these patterns and match them with other trees to extend the record back centuries or even thousands of years. Ice tells its stories differently. In places like Greenland and Antarctica, snowfall doesn't melt away each summer. It compacts into layers of ice year after year, century after century. Air bubbles become trapped in these layers, sealing away tiny samples of the atmosphere as it was long ago. Scientists drill deep into the ice to retrieve cores that are like frozen scrolls, cylinders of pale blue history. Within them, you can find traces of volcanic eruptions, shifts in climate, even hints of how greenhouse gases have risen and fallen over time. Some of the air in those bubbles was last breathed by mammoths, drifting across plains that no longer exist. Stone has the longest memory of all. Fossils, pressed into sedimentary rock, can endure for millions of years. A single leaf's outline in shale, the spiral of an ammonite, the heavy bones of a dinosaur. These are not just remnants of living things, but also snapshots of the environments they inhabited. The type of rock, the grain of the sediment, the minerals that replaced the original tissue, all whisper details about ancient climates and landscapes. Even the absence of certain fossils in a layer can tell scientists when extinction swept across the planet. There is something humbling in realizing how much of Earth's memory lies far below our feet. Mountain ranges were once seabeds, deserts have been forests, and forests deserts. Rivers have shifted, carved, and abandoned valleys, leaving behind sedimentary layers like pages in a book that no one person could live long enough to read in full. In these archives, the past is not an abstract concept, it's physical. You can hold it in your hands. A cross-section of a tree trunk feels smooth under your palm, but it is textured with years. A piece of amber holding a trapped insect contains a moment of movement that stopped millions of years ago but never left. A lump of coal is compressed sunlight from a forest that grew before any human walked the earth. And the reading of these records is not just a scientific pursuit, it's a kind of listening. You listen to the patterns of nature over time. You learn that droughts and storms are not new, but part of a larger rhythm. You see that life has endured through ice ages, through shifts in continents, through the rise and fall of entire species. These archives teach perspective. The timescale of a single human life is short, but the Earth's memory is deep, and it holds more than we can ever witness. These records also connect us to the other ideas we've explored in this journey. Just as light from distant galaxies brings us images from long ago, the layers of the Earth bring us physical touchstones of the past. They are not metaphors or mathematical reconstructions, but tangible pieces of what once was. You can place your hand on a boulder and know that in some form, it has been in that place for hundreds of millions of years, watching mountains rise and oceans retreat. Of course, these archives are not perfect. Fire can erase tree rings. Glaciers can grind layers of rock into dust. Ice sheets can melt, releasing their trapped air to mix with the present atmosphere. Just as with human memory, some pages are missing, others smudged or overwritten. But enough remains that we can see the outlines of the story, a story of change, adaptation, and survival. When scientists work with these materials, they are not only studying the past, they are touching it. Pulling an ice core from the drill and seeing layers of ancient snow is not unlike finding an old diary in an attic, except the diary may be 500,000 years old. Polishing a slice of petrified wood reveals not just the shape of the tree, but the mineral patterns that replaced its living tissue, marking its transformation from life to stone. And in a way, we carry a small part of this process ourselves. We are living on the topmost page of the Earth's diary, walking on the latest layer of its story. Each footprint in mud, each brick in a building, each garden planted in the soil becomes part of the next layer, a faint trace for whoever or whatever comes after us to read. In the next session, we'll turn from the records kept in the land and ice to the records carried in our own bodies. DNA, the code inside each of our cells, is more than a blueprint for life. It is a book that has been passed down through billions of years of evolution, edited and re-edited by the pressures and possibilities of existence. Where the Earth writes in stone and ice, life writes in molecules, and the stories it keeps are just as deep. If the Earth keeps its history in layers of rock and ice, life keeps its history in a different kind of archive, one so small it can fit inside the nucleus of a cell, yet long enough to stretch for billions of years. DNA is not just a chemical that builds our bodies, it is a script that has been copied and passed on through generations, edited by chance, environment, and survival. Every living thing carries this script. It is both a present instruction manual and a record of the past. Your DNA is written in a 4-letter alphabet, A, T, C, and G, standing for 4 molecular bases. The arrangement of these letters tells cells how to make proteins, which in turn build the structures and run the processes that keep you alive. But those letters are not unique to you. They are part of a vast shared text, much of it inherited from ancestors so distant we cannot name them. Some sequences have been preserved for hundreds of millions of years because they work so well that evolution has had no reason to change them. Inside your cells are fragments of history you share with fish, with birds, with ancient bacteria that lived long before the first animals walked the land. The genes that help your cells produce energy trace back to mitochondria, tiny structures that were once independent organisms, swallowed by a larger cell in an act of cooperation that changed the course of life. The genes that shape your spine echo the early chordates, creatures that swam through Cambrian seas 500 million years ago. DNA is also marked by the struggles of more recent times. When a population faces an epidemic, the survivors often carry mutations that help resist the disease. Over generations, these changes become part of the genome story, a faint scar left by the battle. Geneticists have found traces of ancient plagues in human DNA, signatures that tell of viruses and bacteria that swept through long before recorded history. It is not just humans, of course. Every species carries its own genetic diary. The stripes of a zebra, the camouflage of a cuttlefish, the antifreeze proteins in the blood of Arctic fish, all are solutions written into DNA by the long experiment of life. Some entries in this diary are bold, reshaping the organism in obvious ways. Others are quiet, small adjustments that alter the way a protein folds, or the way a gene switches on in the cold. And DNA remembers more than success. Hidden in its text are the ghosts of genes that no longer function, pseudogenes that were once active but have been switched off, like broken tools left in a workshop. There are also fragments of ancient viruses, their genetic material accidentally copied into the host's genome and passed down like unwanted guests who refuse to leave. A surprising portion of the human genome, nearly half, is made of such remnants. Thinking of DNA as a living memory is more than a metaphor. It is a physical record, copied in every cell, each new generation taking the same script and making small edits. The changes are usually tiny, but over thousands of years they can reshape a species entirely. Just as an ice core holds layers of air, DNA holds layers of adaptation. Some changes are responses to climate, others to food sources, predators, or diseases. All are part of the same long story, carried forward in molecular form. One of the most striking things about this record is how connected it makes us. The genetic code is universal to all life on Earth. The same 4-letter alphabet builds mushrooms and elephants, oak trees and jellyfish. This means that every living thing shares a common origin, a single ancestral population of simple organisms that lived over 3 billion years ago. That origin is not just an idea, it is written into the very molecules inside you. When you breathe, the oxygen that fuels your cells participates in chemical reactions guided by enzymes your distant ancestors also relied on. When you heal from a wound, the clotting process is orchestrated by proteins whose designs were perfected long before humans appeared. Even your ability to see in colour depends on pigments that evolved in ancient marine creatures sensing light in shallow seas. The most intimate part of this record is the way it connects you to your personal family history. Half of your DNA comes from each parent, but those halves are themselves mixtures of their parents, and so on, reaching back through a chain of ancestors that includes not only people you might have heard stories about, but countless others whose names and lives have been lost. Their choices, environments, and fortunes have shaped the genetic script you carry. You are, in this sense, a living archive of your entire lineage, and this archive is not static. Every day, your cells copy their DNA to make new cells. Occasionally, small errors, mutations, appear in the copying. Most have no effect. Some are harmful. A few may be helpful. This ongoing process means that even now, in your lifetime, the story is still being written. You're both the product of billions of years of edits and a page where new edits appear. Thinking of DNA this way shifts our understanding of the past. The past is not only in fossils or distant light, it is in the cells of every living being. It breathes with you, repairs with you, and will be carried forward into the future through your children, or through the other living systems you influence in your lifetime. In the next session, we will widen the scope once more, beyond family trees and species histories, beyond Earth itself, to the atoms in your body. These atoms were not born with you, or with humanity, or even with the planet. They are older than the sun, forged in the hearts of stars and in the explosions that scattered the ingredients of life across the galaxy. If DNA is your connection to life's memory, your atoms are your connection to the universe's memory. If DNA connect you to the history of life, the atoms that make up your body connect you to the history of the universe itself. Long before there was Earth, before the sun, before even the quiet swirl of the Milky Way's arms had fully taken shape, your atoms were already in motion, scattered across space, waiting for their chance to gather into something new. Take a single atom of carbon in the tip of your finger. It did not begin here. It was born in the heart of a star, billions of years ago when the universe was young but already restless. In those stellar furnaces, hydrogen fused into helium, helium into heavier elements, each reaction releasing heat and light. For many elements essential to life, carbon, nitrogen, oxygen, iron, the story continued in even more violent places, the supernova explosions that mark the death of massive stars. A supernova is not just the end of a star, it is also a great scattering, a moment when the star's core collapses and then rebounds, flinging its enriched contents into space. The iron in your blood was forged in such an explosion. So was much of the calcium in your bones. These elements drifted through the galaxy as dust and gas, mixing with the raw hydrogen and helium left over from the Big Bang. Eventually gravity gathered them again, pulling them into clouds dense enough to form new stars, and around some of those stars, planets. Earth was one such place. From the debris of countless older stars, our planet condensed, carrying with it all the ingredients needed for oceans, rocks, air, and life. Those atoms became part of minerals, water molecules, and organic compounds. Some were locked in stone for millions of years before erosion freed them. Some cycled through plants, animals, and soils many times before ever finding their way into you. This cycling means that the atoms in your body have belonged to countless other things before you. The oxygen you just breathed might have been in the lungs of another person years ago, or in a whale crossing an ocean, or in the leaf of a tree turning sunlight into sugar. The calcium in your teeth could once have been part of a seashell resting on the floor of an ancient ocean. The hydrogen in your water is older than the sun itself, a relic from the very beginning of time. We don't usually think of ourselves this way, as temporary collections of borrowed matter, but it is a gentle and grounding thought. You're not made from new materials, you're made from the oldest materials there are, arranged in a way that is unique to this moment, and one day those materials will move on to become part of other things, other lives, other stories. This idea is not just poetic, it is chemical fact. The atoms that make up your body are constantly leaving and being replaced. You exhale carbon atoms that were part of your breakfast a few hours ago. You shed skin cells, losing millions of atoms each day, while absorbing new ones through food, air, and water. The boundary between you and the rest of the world is porous, and the exchange is continuous. There is comfort in this continuity. It means that you are linked to everything else by a constant sharing of substance. You are part of a cycle that is far older and larger than yourself, one that does not end when you do. Your matter will keep moving, keep forming new bonds, keep taking new shapes, long after your particular arrangement has dissolved. Some people call this the cosmic recycling program, but that phrase feels almost too tidy for something so vast. In truth, it is more like an endless river with many branches, flowing through stars and planets, oceans and atmospheres, living beings and the spaces between them. Sometimes the river pools for a while, in the form of a mountain, a glacier, a living body, but eventually it moves on, carrying its particles to new destinations. The age of the atoms themselves is staggering. Hydrogen, the simplest and most abundant, was formed about 13.8 billion years ago, in the first minutes after the Big Bang. Helium joined it soon after. The heavier elements took longer, waiting for stars to form, live and die. The youngest of the elements in your body may still be billions of years old. Knowing this changes how you see the past. The past is not gone in any absolute sense. Its materials are still here, woven into the present. The same atoms that form the bones of dinosaurs are part of the rocks beneath your feet. The same oxygen that filled the lungs of the first mammals moves through your bloodstream right now. In this way, you carry more history than you could ever remember, more than any photograph or fossil could hold. And it also changes how you see yourself in the flow of time. You're not just moving forward into the future, you're carrying the past with you physically. You're a walking museum of cosmic history, though not the kind with dusty halls and glass cases. Your exhibits are alive, circulating in your blood, strengthening your bones, helping your neurons fire. One day, long after you're gone, some of your atoms may travel far beyond Earth. They might become part of a spacecraft, part of a seed drifting in interstellar space, or part of a new planet orbiting another star. They might take forms that life as we know it cannot imagine. In this way, a part of you could continue travelling, not only through space, but through time, carrying traces of this moment into a future you will never see. When we think about whether the past disappears, the answer from the atoms is quiet but clear. The forms change, the arrangements dissolve, but the substance endures. Matter is conserved. The universe keeps everything, just not always in the same shape. In our next part, we will leave these tangible records, fossils, DNA, atoms, and step into a softer place, the wind down of our journey. We'll explore what all these ideas mean for the way we live in the present and for the way we carry the past, even when we cannot touch it or return to it. We'll see how the science of time folds gently into the philosophy of being, and how the persistence of the past can be both a comfort and a mystery. If the past still exists in the matter and memories of the universe, it also exists in you in a more immediate way, not just in your DNA or your atoms, but in the way your body keeps time. You may not carry gears or pendulums inside you, but you are full of rhythms, some so precise they could guide a spacecraft, others so subtle you hardly notice them. Your heart is the most obvious clock. It beats in a steady rhythm, a quiet drum marking the passage of moments whether you're running, resting, or dreaming. The pulse in your wrist is more than a sign of life. It is a measurement of time in its smallest, most personal units. A lifetime is measured in these pulses, and though each beat is brief, the pattern they form can stretch over decades. But the body's clocks run deeper. There is your breathing, slow or quick, depending on what you're doing. A cycle that began with your first cry, and will end only with your last sigh. There are rhythms in your brain, waves of electrical activity that rise and fall in patterns linked to thought, rest, and dreaming. There is your circadian rhythm, the roughly 24-hour cycle that makes you sleepy at night and alert in the day, tied to the turning of the earth beneath the sun. These rhythms are not just about keeping time, they are about listening to it. Your body responds to the lengthening days of summer, the shortening days of winter. It adjusts to the pull of the moon in ways we still do not fully understand. It listens to the signals in food and light, in temperature and darkness, and translates them into the right time to wake, to eat, to heal, to grow. In a way, you are both the clock and the observer of the clock. Your cells keep their own schedules, dividing, repairing, and replacing themselves at different rates depending on where they are in your body. Skin cells turn over quickly, bone cells take their time. The lining of your stomach is replaced every few days, while some neurons in your brain will last your entire life. This means that different parts of you are living in slightly different timelines. A quiet layering of past and present inside your own skin. Even your memories are a form of timekeeping. They do not measure minutes or hours, but they hold the order of events, the sequence of cause and effect. They tell you what happened before and what came after. They anchor you in a personal history that is separate from the clock on the wall but no less real. Without this inner record, time would be only a blur, a series of unconnected moments. And then there is temperature, another subtle way your body listens to time. Your core temperature rises and falls in a daily cycle, warming slightly in the day and cooling at night. This rhythm helps regulate sleep, mood, and alertness. Even the tiny fluctuations you do not notice are part of a larger conversation between you and the time flowing around you. When you think about it, the line between keeping time and being time begins to blur. You're not outside the flow, watching it go by. You are part of it, shaped by it at every level. The signals your body listens to, light, heat, sound, gravity, are all echoes of the universe's own clocks. The Earth spins, the moon orbits, the seasons change, the stars drift, and those motions set the rhythm for the life you live. Some of these rhythms are ancient. The circadian cycle is older than humanity, shared by plants, fungi, and even some bacteria. The heartbeat, in different forms, runs through the animal kingdom. Breathing is shared by creatures that live on land and in water. These clocks are not inventions, but inheritances, passed down because they work, because they keep life in sync with its surroundings. It's easy to overlook all of this, to think of time as something measured only by the devices we make. But the truth is that you carry an entire suite of clocks with you at all times, tuned to different scales, seconds, hours, days, years. Together they weave your experience into a continuous thread, one that connects your personal present to the deep past. And they are not perfect. Like any clock, they can drift. Jet lag is what happens when your inner clocks are out of sync with the light-dark cycle outside. Seasonal changes can tug at your mood because the length of daylight is a powerful hand on the dial of your circadian rhythm. Illness, stress, and age can alter the tempo of your heart and breathing, changing how you feel time passing. Yet even with their imperfections, your body's clocks keep you anchored. They remind you that time is not only something you think about, it is something you live. You don't have to see a sunset to know the day is ending. Your body will have already felt the change. You don't have to watch a second hand to know that a moment has passed. Your heart will have already marked it. So when we ask whether the past disappears, it's worth remembering that part of it stays in motion inside you. Every beat of your heart and every breath you take is part of a sequence that began long before you were aware of it and will continue until your last moment. You're not just moving through time, you are one of its instruments. In the next session, we will take this idea further, to the now itself, the moment you're in right now. We will look at how this now is not a single point but a soft blur that holds pieces of the past and hints of the future, and how living in it connects you to the entire span of time we have been exploring. We often speak of the past as if it has slipped away, vanished into some unreachable distance. We imagine it as shadows in the dark, as fading voices, as rooms we once walked through but can never enter again. But perhaps the past is not a ghost at all. Perhaps it is more like a companion, quiet, steady, and always present, walking beside us whether or not we turn to look. The past is the ground beneath your feet. Every step you take rests on layers of events that happened long before you arrived. The soil that feeds a garden may have been part of an ancient forest. The street you walk down may follow a path first worn by other travellers centuries ago. Even the air you breathe has been here before, inside other lungs in other times. It is not just memory, it is matter, cycling through the world, touching you in ways so ordinary you almost forget to notice. We live among echoes, not the kind that fade quickly, but the kind that linger, folded into the shape of everything around us. The warmth of sunlight is not just heat. It is a message from the past, a reminder that the sun's light began its journey to you 8 minutes ago. The wood in your desk holds years of rain and growth. The words you read were shaped by the language that grew slowly from the voices of those who came before. Even your own body is a collection of these echoes. The curve of your hand is an inheritance from your ancestors. The cells in your skin are made from atoms that once burned in the hearts of stars. The thoughts you have are carried by patterns of neurons that evolved over millions of years, shaped by the challenges and wonders faced by those who lived before you. In this way, the past is not something that exists only in photographs or dusty journals. It is woven into the present moment, as much a part of it as your own heartbeat. The chair you sit in, the sound of the wind outside, the food you eat, all are made of stories that stretch back further than you can imagine. To live in the present is to live surrounded by those stories, and the past is not here to haunt you. It does not follow you with the intention of dragging you backward. It simply exists, like a familiar landscape you pass through on your way forward. Some parts you notice, others fade into the background, but they are always there, holding you up, giving shape to where you are. Think of it like walking through a forest. The trees around you are alive in the present, but they also carry their own deep histories. Rings inside their trunks record the rhythm of years. Roots follow old paths in the soil. Fallen leaves decay into the ground, feeding the next season's growth. The past and the present are not separate here. They are intertwined, each sustaining the other. It is the same with us. We carry the past in ways we cannot set down, and we are carried by it in return. The knowledge you have, the instincts you trust, the traditions you follow, they are all gifts left behind by those who face their own lives with the same uncertainty and hope you feel now. Even the challenges you face have their roots in the past. Problems, like gifts, are passed down. A crack in a building's foundation may begin decades before anyone notices. A forest's health may depend on seeds planted generations earlier. The present is never just itself. It is always a continuation of what came before. When you see the past as a companion, you can also see how it shapes your relationship to the future. You're not standing at the edge of time, watching the past disappear behind you. You are standing on it, carried forward by it, even as you add your own layer for others to stand on later. This thought can be comforting. It means you're never alone in the truest sense. You're walking in the company of every step that has brought you here. Not only your own steps, but the steps of those you will never meet. You're surrounded by their choices, their creations, their mistakes, and their love, all folded into the world you inhabit now. It can also be grounding. When the present feels uncertain or fragile, it helps to remember that the past has already endured more than you know. Life has persisted through ice ages and extinctions, through shifting continents and changing skies. The fact that you are here means that somewhere along the way, the past found a way to keep going. So tonight, as we slow our pace and let our thoughts settle, you might picture the past not as something slipping away, but as something walking quietly beside you. It does not ask for your attention, but if you look to the side, you will see it, not as a shadow, but as a steady presence, keeping time with your steps. In the next session, we will look more closely at this journey we make through time, not as a straight path, but as a fine thread stitching its way across a wide canvas. Each moment you live is a stitch in that tapestry, and when you've moved on, the stitch will remain, beautiful, intact, and part of the larger pattern. Imagine a vast canvas stretched out before you. It is so wide you cannot see its edges, and so tall you cannot see its top or bottom. This canvas is time itself. The colours spread across it are the moments of history, swirling, layered, some bright and bold, others soft and nearly transparent. Your life, your now, is the thin line your brush moves along as you paint. The line is narrow, yet it is alive with detail. You can feel the texture of the canvas beneath your hand. Each stroke you make connects to what came before and to what will come after. The moments behind you do not vanish. They remain in the painting, part of the composition forever. The moments ahead are still blank space, waiting for the first touch of colour. We often imagine the present as a point, a single, vanishing instant between what was and what will be. But the truth is softer. The present is more like a thin, moving strip across the canvas, wide enough to hold pieces of the past and hints of the future. You carry what just happened, still warm, still unfolding, and you lean into what is about to happen, shaping it with each choice. Like a needle stitching through fabric, you move along this strip, leaving behind a line of thread that becomes part of a much larger design. Each stitch is permanent once it's made. It doesn't unravel when you move forward. It remains, joined by others until the pattern takes shape. You may not be able to see the full design, but it is there, built from every movement of your hand. If you step back, far back, the narrowness of your present becomes clear. The canvas holds moments you will never see, both far behind and far ahead of where you are now. Entire lifetimes have been painted in the sections before yours, each stroke layered over others, blending and contrasting. Civilizations have left their marks in broad sweeps of colour, then faded into the background as new layers were added. Yet nothing has been erased. It all remains, part of the texture you paint upon. You might wonder what becomes of your own line once you've moved on. Will it be noticed? Will anyone step close enough to see the shade of colour you chose, the small curl in the brushwork? Perhaps, or perhaps not. But in the grand view, your line matters because it connects. It bridges what came before to what comes after. Without it, there would be a gap in the design. This way of seeing time changes how you think about the fleeting nature of the present. It is fleeting, yes, but it is also enduring. Once a moment is painted, it cannot be unpainted. Even if the colours fade, the layer is still there, influencing everything that comes after. Your laughter this morning, the decision you made last week, the way you showed kindness to someone years ago, all of these are strokes on the canvas, still shaping the patterns around them. And the canvas is not yours alone. Millions of other brushes move alongside yours, some crossing paths, some painting in parallel. You share the strip of now with countless others, friends, strangers, animals, trees, even the clouds drifting above. Their colours mix with yours at the edges, creating blends you could never have made alone. Sometimes these blends are harmonious, sometimes they clash, but together they form the living present. What is striking is how much of the painting you carry with you without realising it. The techniques you use with your brush are learned from earlier strokes, from your own past, from the examples of others, from the long tradition of strokes left by those who painted before you were even born. The way you hold the brush, the pressure you apply, the colours you reach for, all are shaped by what has already been painted. And just as you're not the first to work on this canvas, you will not be the last. The line will keep moving long after your brush is still. Others will take up the space you once held, adding their own marks, blending their colours with the traces you left behind. In this way, the present is not just a personal experience, it is a shared act of creation, part of something continuous. If this thought feels vast, it is meant to. The present is not small because it is brief. It is immense because it is connected to everything else. It is the place where the entire weight of the past meets the open space of the future. It is where you stand every moment, stitching yourself into the greater tapestry. So when you feel rushed, when the present seems to slip away too quickly, you might picture it differently. You might imagine your brush slowing down, letting the colour sink deeply into the canvas. You might feel the thread in your hand, steady and strong, each stitch anchoring you to the whole. In this way, the present is not something you lose. It is something you leave behind, intact, part of the work forever. In the next session, we will take one final step back from the canvas to see yourself not only as a painter, but as part of the painting. You are made of the past's colours, moving through the present's light, carrying the seeds of the future in your hand. And when the time comes to rest, the universe will continue to keep its quiet watch over all that has been painted and all that is yet to come. You have walked with me through the layers of time, from the vast sweep of the universe's history to the quiet beat of your own heart. We have stepped into the past through light that has travelled across unimaginable distances, through fossils and ice cores, through the patterns of DNA, through the atoms that are older than the Earth itself. And we have returned here, to this moment, carrying all of it with us. You are made of the past, not just shaped by it, not just influenced by it. You are built from it. Every part of you is a collection of stories that began long before you could tell them. The warmth in your skin is powered by a star's light that left the sun minutes ago. The iron in your blood was forged in a star's death billions of years in the past. The instincts you trust, the languages you speak, the way you move through the world, all were formed in moments that still live, stitched into the present you now inhabit. And you are also a traveller. You move through the present, leaving behind moments that will, in turn, become the past for someone else. You carry seeds of the future, not only in the literal sense of children, inventions, or words passed on, but in every action that touches another life, every kindness or thought or decision that alters the shape of what will come. Travelling through time is not like crossing a landscape. There is no road ahead, no visible horizon. It is more like drifting along a river whose source you cannot see and whose end you will never reach. The current carries you, and you leave ripples that spread in ways you may never know. Some of those ripples will fade quickly, others will travel far, touching shores you cannot imagine. The universe will keep its watch. Stars will continue to burn and fade. Galaxies will drift apart, the Earth will turn, and the Moon will keep its silent orbit. The patterns of life will shift, but the matter and energy that make them will remain. Somewhere, in all of that, the traces of you will linger. This is not a burden to carry, but a comfort to rest in. You are part of something that began long before you, and will continue long after. The line of time you walk is yours alone, but it is also woven into countless others, a thread in a fabric too large to ever see in full. You are not separate from it. You're not an observer standing outside. You're inside the story, shaping it as it shapes you. When you sleep tonight, you will still be moving through time. Your body will keep its quiet rhythms, heartbeat, breath, the slow repair of cells, and your mind will wander through dreams. Time will pass gently, measured in cycles of breath and the soft turning of the earth. And in the morning you will step into another present, carrying all that came before. It is strange and beautiful that something so vast can be so personal. The same laws of physics that govern galaxies govern the rise and fall of your chest as you breathe. The same principles that preserve the memory of ancient light preserve the memory of your own moments. You're a microcosm of the universe, an echo of its beginning, a participant in its unfolding, a fragment of its future. So sleep, little traveller through time. Let the weight of what you have carried settle gently. The past will not leave you. It will walk beside you into tomorrow, as it always has. The future will wait patiently for your arrival, and the present, this thin, luminous line, will hold you until it is ready to join the rest of the tapestry. As you drift toward rest, imagine yourself joining the universe's quiet watch. Somewhere, far beyond what you can see, a star is shining, its light already on its long journey toward you, though it may take centuries to arrive. Somewhere else, a planet turns slowly in the dark, unaware of your existence, yet made of the same ancient dust that lives within you. The universe does not hurry. It breathes, expands and unfolds at its own gentle rhythm, and tonight you can move with it, letting time flow around you like a soft and endless tide. In dreams, perhaps you'll wander into moments you've never lived, or return to ones you thought were lost. Perhaps you'll stand on the surface of another world, beneath a sky full of unfamiliar constellations. Or perhaps you'll simply rest, no journeys, no destinations, knowing that even in stillness, you're already travelling through time itself. When morning comes, the motion continues. You'll step once more into the moving present, adding your own colours to its vast canvas, your own threads to its intricate weave. You may not see the pattern, but you'll feel its pull, the quiet way it connects you to everything that has ever been and everything still to come. And perhaps somewhere deep inside you'll remember, time is not something to chase or conquer. It is something to move with, a companion, patient and enduring, walking beside you through every moment. So close your eyes, let the stars keep their watch, let the earth turn, let your breath find its calm rhythm with the cosmos. You are here, in this moment, in this body, in this life, and that is enough. Sleep well, little traveller. The universe is vast, but tonight it has made space for your rest.